Welcome back, Picture Shufflers. We are here with day 3. We are going to wrap up this game today and then let you all make the aesthetic changes that you might want from here. So, the game is working, the game is doing what we want. However, when we start this game, we see the image in the final form. The game is over without having to do anything. How boring. There's nothing to do. That's like having to shuffle your own Rubik's Cube. Blah. So what we would love to do is be able to initialize the board to start the way we want it to show the user what the image should look like in the end. Show that to them for a few seconds. Then shuffle up the board in a way that's solvable. And then from there, go ahead and let them rearrange like crazy. Now, I'm saying in a way that's solvable, not because I know for a fact that all board positions aren't solvable, but simply because we want to be careful that we don't just do random willy-nilly stuff. So when we shuffle, we are going to do shuffles of just swapping a bunch of positions that are neighboring to one another over and over and over again until the image is nice and shuffled up. Then we know that it's doable because what we've done is always just moved one position away, so it's at least going to be solvable. It's possible all positions would be solvable, and then it's just a matter of putting those numbers in random locations on the grid. But oh well, let's go ahead and play it safe. It'll actually make the code a little bit more interesting as well. So that's where we're going to start. We want to think about doing that shuffling. But first I'm actually going to show you what that would look like in your graphical game class. What does it mean to show the original screen first, then shuffle the board, then go on from there. So inside of your Run Graphical Game class, we're basically going to want to keep some kind of a timer for ourselves so that we can keep track of where we are. First, show the user the original picture, then shuffle it up, then let them play. So we kind of want to have those 3 phases. The easiest way to have those 3 different phases when we're inside of the realm of graphics is to just go ahead and use the timer. So at the top of your Run Graphical Game class, we're going to create a timer variable that we're going to set equal to 0. Then inside of our draw method down below, we're going to just increment that timer. So anytime we run that draw method, the timer is going to go ahead and run as well, or increment. So then what we want to do is we want the first few frames of the game to just be showing the image. So if our timer, let's say for now, is less than, 50, because 50 frames goes by really fast in this game, but if our timer is less than 50, we're going to go ahead and just display the image. So we'll have that background command that you see that was there. That I think says background like 180 or something very close to that. And then it says something like display, what does it actually say? Let's be careful here, Miss Glenn. It says display.draw grid, and then it says game.getGrid. So from here, what we want to do is, that's just displaying it. Next situation would be when we do the shuffling. We want to be shuffling for a very short amount of time, and we'll just let the user know that that's what we're doing. So we're going to say else if, and then we're going to put a very short window for the timer. If the timer is greater than or equal to 50, but it's also still less than, let's say 75 for right now, then that's when we're going to want to do our shuffling. So we're going to put text onto the screen. We're not going to display the board at all. We're just going to put text onto the screen that says shuffling, so they know that we're shuffling, and that message is going to display really, really fast. And we're going to want to call our shuffle board method to shuffle up our game board. However, that's not a method that yet exists, so this will show up in red as soon as you type it. That's totally fine. And then else would mean we are now at a case of we've shown the original game, we've done the shuffling, so now else is play the rest of the game. So inside of here, that's where we again are going to want to display the grid. Draw grid of game.getGrid. And then here's where you would want to do that is game over check. So if game.is game over that you already have, and then we'll put the text that says you win. Great. So the only other thing that you could do is inside of your mouse release method, you could make sure that your timer is greater than 75 before you actually would run that move method. So you could put that into your mouse release if you wanted to, but you do not have to. If you want to go back and replay those 30 seconds over again to hear me say that again, you are welcome to do so. That's the beauty of having a video. All right, so with all that in mind, this is now going to give us that like pause effect of display the picture originally, shuffle it all up, then let us play the game. The thing that we have to go do now is backfill and figure out how the heck do we actually shuffle it all up. So let's do that. Inside of our game board class, we're going to make a method that is a public void shuffle board method, because that's what we called it in the other class. It doesn't need any inputs. Its job already, it knows that it's just supposed to go ahead and shuffle the board. And then what we're going to do is we're going to use a for loop just to do something for a certain number of times. Recently, our for loops have all been about like looping over something or visiting specific locations. I'm going to use a general for loop just to say like for, to do something like a repeat 10 times kind of a thing. So because I'm in pseudocode land right now, I'm going to just write it as repeat 10 times. But that's a for loop that I just want to go for 10 times. And the thing that I want to do is I want to pick a random location within the grid, and then I'm going to pick a random neighboring position. So I'm going to create an int rand x that's going to be random number between 0 and whatever the grid dot length -1 would be for our game. And then I'm going to do that same thing to create a random y variable. It's between 0 and whatever grid 0 dot length -1 is for our game. And that's going to be the random position. And then from there, I'm going to go swap with any neighbor that I want to. Now you could make this pretty straightforward and just say that you're always going to swap with the right neighbor or the left neighbor. However, you might not always have a right neighbor or left neighbor, so you could leave it up to chance as well if you wanted to. So for right now, just for the ease of this shuffling method, let's go ahead and say that we're always going to swap with the neighbor that's below. And if you don't have a neighbor that's below, oh well, we'll skip that one in our swap and we'll go on to the next one. Remember, this loop is running 4 times, and then for, well, 25 frames of draw, we're calling that shuffle method. So we'll get enough shuffling done, even if a few aren't what we want them to be. If you want to, you could make more random number variables so that you choose whether you're going to subtract from a row or a column, or sorry, whether you're going to go to a neighbor position of a row or a column, and whether you're going to add or subtract. You could add in random numbers to do that if you wanted to, but we don't have to. So then what I'm going to go do is I'm just going to call that switch value method that we had already made. So switch value. And what I want to do is I want to switch the value of that random x, random y, which we actually do know for a fact is going to be within the grid because I'm setting the parameters to be within the grid. But then I'm just going to say that we're going to use rand x, and then we're always going to do rand y plus 1 to get the space that's below it. And we're always going to shuffle in that way. So when you do that, turns out that I don't actually know that this is a position within the grid. So it was a really good thing that we did in fact check that is in grid method. It's almost like I knew what was coming. But now that I know that I have that check in place, it's okay to go ahead and pass this in. If there is no neighbor below, it will be caught. We won't change those 2 values, and we'll just move on to the next iteration of the for loop. And that's it. If you want to add in more to make this do 2 other variables, you can add in another 2 variables, one that's just like a value of 0 or 1. 0 would then attribute to changing a row. 1 would attribute to changing a column. And then another one that's 0 and 1. 0 would mean that we add. 1 would mean that we subtract. And you could just add those bits in, so then you would have multiple checks in here, but you could have a more robust switch value call in your shuffle method or in your shuffleboard method. And that's it for day 3. Happy programming!